Okay, let's thank Jennifer again. And next we have Kiran from the Basis Institute, who's going to be talking about the overlap of choreographic programming with game theory. Take it away.
Awesome, perfect. I'm Kiran. I'm a research scientist at the Basis Institute. Research Institute, it's a small sort of non-profit research institute based in New York. And today I'm going to be presenting about this work on behalf of my collaborators called Pact, Choreographic Languages for Agentic Ecosystems. And quickly, before your eyes glaze over, I just want to say this is not like about LLMs. So, pay attention. This is like really fun stuff. I'm really pleased to present this to you all. But before we begin, a sort of small amount of motivation. So, for better or for worse, and maybe for worse, we seem to be very rapidly heading towards a world populated by sort of these ecosystems of agents talking to each other. And so one of the questions that we, is going to become increasingly important as we move forward is whether we can trust these systems of agents talking to each other. And obviously, yeah, it seems not really. And unfortunately, it seems with the current state of the art, the main medium by which agents sort of communicate is through natural language. So if I had sort of two agents and I wanted them to sort of talk to each other and maybe conduct some kind of transaction, then the way this would operate is pretty much through the agents sort of talking to each other in natural language, in English. And they just chat. And so this transaction would occur in a purely sort of ad hoc, informal and unstructured way. And if you've been sort of following the news, or you may have seen any number of sort of somewhat humorous, maybe somewhat depressing stories of these agents going awry and sort of doing various kinds of incorrect things. So overall, these things are very vulnerable to even basic, very dumb things like prompt injections or coercion, and sometimes they just do the wrong thing entirely. And at a high level, the issue here is that natural language as a communication substrate really provides no guarantees on the kind of protocols that they run. So this is kind of the motivation that led us to sort of look into this problem. And the question that we were trying to sort of investigate was whether we can use sort of choreographic languages as a formalism to enable trust in these kind of agentic ecosystems. And in this process, we kind of landed on a rather nice place in the design space that has sort of pretty much nothing to do with LLMs at all. It's rather nice sort of unifying of these ideas from choreographic programming and also economic game theory. And that's what I'm very happy to present to you today. So the sort of rest of the outline of my talk is as follows. I'm going to first start off by sort of motivating how choreographies kind of fall flat in these untrusted ecosystems. And then I'm motivated by these failures. We're going to look at how we can extend a sort of basic choreographic language to incorporate notions of game theory. And then the third thing we're going to do is using this interpretation as a game theory as a sort of formal game, we can actually treat endpoint projection as a means to do sort of decision policy solving. This is kind of the bread and butter of game theory. And finally, I'm going to conclude with some directions for future work that I'm interested in looking into. I'd love to hear any of your comments and criticisms, or maybe collaboration if anyone is interested. So without further ado, let's dive in, starting with the limitations of choreographies. So to kind of motivate this, let's look at the bread and butter of choreographic programming, and that is the bookseller protocol. So the high-level idea, as I realize, I guess from the intro talk, not everyone here knows choreographies. We have these kind of two participants. We have a buyer and a seller. The buyer would like to sort of purchase a book, and the seller would like to, I guess, make a profit and sell the book. So using a choreographic language, we can represent this in a concise, sort of nice, elegant, global perspective. So the choreography describes how this transaction should proceed. So starting off with the buyer is going to send their title over to the seller. And so once the seller kind of receives the title of the book the buyer would like to buy, the seller is going to perform a sort of local computation. They're going to work out, given the title, what price they want to set for that book. And then they're going to send that price back over to the buyer. And once the buyer receives this price, the buyer is going to then do their own local computation and decide whether they want to accept. So for example, whether this price is within their budget. And if they do decide to accept, then we can sort of send this over to the seller, and we can conduct a transaction. So all in all, a pretty nice, clean, and elegant description of this sort of protocol that several talks prior have demonstrated are substantially more concise than maybe writing the individual programs. But this standard choreography kind of falls flat if we want to sort of run it in an untrusted ecosystem. And that's because it kind of overlooks one sort of core core question that arises in these settings. And that is, why would buyer or seller actually want to follow this protocol? Right? In some sense, the choreographic protocol is overly prescriptive in the sense that it dictates what the local computation should be. And you can think in sort of an untrusted ecosystem, there's no way that the choreography can actually enforce what an agent does locally, right? You can think sort of maybe a strategic or unethical seller might actually choose their prices based on maybe a prior belief about the buyer. Maybe if the buyer is rich, we can get away with charging them more. And similarly, a strategic buyer might decide to accept lower prices if the seller is kind of desperate to get rid of the book. And so the question that this kind of raises is, how can we reason about these kind of strategic interactions between these conflicting objectives in a principled way? And as it turns out, there's an entire field of research whose bread and butter is exactly answering this kind of question, which is formal game theory or economic game theory. And so the core of this idea, of this work, is to sort of investigate whether we can actually bridge between these two formalisms, whether we can take choreographic languages and we can somehow map them over to formal games. And this brings us on to the next part of the slide, which is how we can actually map a choreography or extend a choreography to correspond to a formal game. And as it turns out, we can do this in sort of 4 simple steps. So let's take a look at our initial sort of buyer-seller protocol that we walked through earlier. So the first thing that we want to do is, so how can we turn this into a game? The first thing that we want to do is we want to take the local computations that we've already said are sort of overly prescriptive, and we want to sort of change those into agent decisions. In particular, there's no way of enforcing that an agent is going to run a particular local computation. So to really be faithful to what's actually executing at runtime, we should really treat this as a sort of a non-deterministic choice. And in a game theory parlance, this would be sort of agentic. These would be sort of decisions where each of the participants can make kind of strategic actions in conformance with kind of like the types that are required. So in this case, choosing a price or choosing whether to accept. The next thing is, now that we've expressed these agent decisions, we need to reason about what are the factors that influence what decisions an agent would take. And in this case, the utility of a seller in this protocol is kind of explicitly encoded. The seller gains the monetary value of the transaction. But what about for the buyer? So in this case, the buyer's profits are kind of implicitly described. The buyer receives the book, but there's no real sort of explanation of how this translates to a kind of quantitative utility. So the next component that we want to extend is we want to extend this language to include sort of declarations of utility. In this case, this value statement declares that the buyer's utility in this game is kind of a function of this property of the quality of the book. And so now our choreographic language has been extended to explicitly describe the utility of all participants. Now, the other thing to think about is the quality here. Where does that come from? This is kind of a property that is of strategic relevance to the game, right? The utility of the buyer is going to depend on the quality of the good that actually gets sent over. But it isn't something that any of the agents actually choose. The book has a certain quality that's kind of pre-described outside of the game. So the next thing that we want to do is we want to take any exogenous variables like this, and we want to the game theory parlance here is to kind of treat these as nature variables. These are kind of dictated by the world outside of the game, but these are relevant for the sort of the game that we're playing. And the final, and the quality is kind of an assumed prior about the world. So when each person or participant interprets this program, they're going to have to apply their own priors about what they believe the distribution of quality of these books are. And so now all of the exogenous variables in this game are explicitly described as well. And the final component that we need to modify is just in this transaction. If we're running this in an untrusted environment, this has to be a sort of atomic step, because I could sort of send you the money and you could walk away without sending me the book. So really we need some sort of language primitive for atomic exchanges between participants to really capture a game faithfully. And in theory, you could see this as being built on top of various kind of distributed consensus protocols if you wanted to implement this in a distributed system. So with this, now we have this choreographic language that has been extended to formally map to a sort of game-theoretic game. And to kind of like consolidate this mapping, we can actually take this choreographic program and we can map it in a mechanical way to sort of notations from game theory. And in particular, I'm going to map it to this notation called a multi-agent influence diagram, a MADE diagram, or a MADE graph. And we can do this sort of mechanically. So we can take any of the agent decisions, and these will become sort of decision nodes, colored by the participant who is making the decision, and the edges represent dependence. So in this case, the buyer's decision to purchase the book will be dependent on whatever price the seller sends. And you can work this out sort of automatically using a sort of information flow analysis over the choreographic program. Next, for any sort of utility and exchange of sort of funds, we can represent that as utility nodes, again using a similar information flow analysis to work out the dependence between these different decisions. So the utility of the seller is going to be dependent on what price they set, and similarly for whether the utility of the buyer is going to be dependent on whether they decide to purchase the book or not. And the final component is we can take any nature variables and we can represent these as sort of nature variables. So they also influence the outcomes of this game. And so with this, our choreographic program now corresponds one-to-one with a sort of formal game-theoretic game. And so why is this useful? Well, game theory is all about sort of answering questions about expected payoff, and in particular, things like how should I choose a decision policy, right? This is kind of a specification for an interaction, but I haven't really specified how agents are going to make these decisions. And if we map it to a formal game, we actually have a principled way of answering these kind of questions. So this brings us to sort of the third part of this talk, which is how we can use sort of endpoint projection as a means for decision policy solving. And I think this is kind of like the coolest part of this work. So I'm really excited to talk about this, but I just want to say like this is going to be a little bit, it's going to be a little bit subtle, a little bit like kind of mind-bending. So just be prepared. Okay, so consider that you are a buyer participating in the bookseller protocol. So you're participating with some seller. You send over the title of the book that you'd like to buy. The seller sends you back a price. And now you are faced with making a decision, right? I need to choose whether I would accept this price or I should walk away from this transaction. And so how should I work out whether I should accept this price? So game theory tells us we should accept this price if our expected utility from this transaction is going to be positive. In that sense, this seems like a good idea. But really, the utility of the buyer in this transaction is going to be a function of the quality of the good, right? So the question really boils down to, well, what is the quality of this good? Now, unfortunately, as you may have noticed, the quality of the good is something that only the seller knows, right? As a buyer, before I purchase the good, I don't really know if it's good or bad, at least in this transaction. And so the question then devolves into something of, well, how did the seller choose the price, right? The only information that we know is the price the seller has given us. So we need to work out, okay, well, maybe we can infer what the quality of the good is given the price that we see. And so how can we answer this question? Well, the way that a strategic buyer might do this is by sort of running a simulation, not sort of actually running something, but in their head. So how does this work? So the buyer is going to kind of simulate in their head an execution of this whole protocol. So they're going to say that, okay, there's a buyer and a seller. And in this sense, they're going to extend this model with an additional actor called like the world. And the world is going to represent sort of exogenous variables as we've seen before. So the world might sort of choose some quality for the book at the start of this interaction. And then it's going to send it over to the seller. And the seller, once it receives this and receives the title, is then going to sort of locally do some computation to work out how it can maximize its own profit, knowing these values. And then it's going to send over a price over to the buyer. So this is kind of how the price is computed as a function of the quality of the good. So how exactly is that done? Well, this really boils down to how did the seller choose to maximize profit? And this is kind of the cool part, right? Well, how did the seller choose to sort of maximize their profit? Well, the seller would have recursively run a simulation themselves, right? In some sense, the seller is kind of trying to work out what is the highest price that I can sell for this, set for this book that the buyer is going to accept. And this corresponds to running a sort of simulation in its own head, and it's going to sort of simulate a smaller version of the game. And it's going to work out, okay, well, assuming this model of the buyer, who doesn't know the quality, if I set this price, they may accept. And so in this way, we have this, and we can sort of extend this ad infinite. And so this seems like a sort of contrived model. It's actually a sort of idea from cognitive neuroscience. And this corresponds to a theory of mind. And this is actually a good model for how like a lot of humans communicate, etc. And the reason that we chose this kind of formalism is it turns out that there have been recent sort of developments in other PL languages that allow sort of efficiently solving queries over these kinds of recursive probabilistic models. In particular, there's this language called Memo that allows solving this. And so kind of the way that Memo answers queries of this is you can treat these recursive models as a sort of recursive probabilistic program. So in this case, when the world chooses a quality, this can be thought of as sort of sampling from some random distribution. And then this quality is sent over to the seller, and the seller is going to sort of sample from another distribution conditioned on the value of the quality. And then you can sort of, this distribution itself can be another recursive model, but if we kind of cut off the recursion at this point, then we have this model that represents what the buyer is kind of imagining the world to execute. And what the buyer is asking is, what is my expected utility from this interaction? And in other words, this is nothing other than asking a query about sort of computing an expected value of this expression here, which is saying that if the quality is high, then I'm going to get 180, otherwise I'm getting 100. And so the expected utility is just going to be that outcome versus subtracting the price. And so if we can sort of compile this down to sort of a recursive probabilistic program, then languages like Memo allow us to efficiently solve for decision policies. So this is exactly what we do. So we can take our sort of choreographic program expressed as expressed in this language, and then we can do endpoint projection and map these into Memo programs that represent sort of theory of mind computations from the perspective of each of the participants. And in this process, you can inject in sort of priors about your beliefs about the world, etc., and so forth. And in this process, we can sort of solve for decision policies on how you should actually choose your distribution on when you're making a local choice. And one of the cool things about this is kind of the buyer-seller protocol is kind of like the bread and butter of choreographic programming. It's something that I'm sure you've read in lots of papers. And the cool thing about this is we can take this sort of bread and butter program, we can actually recreate kind of rather interesting economic phenomena. So you can kind of get like a market for lemons where a strategic seller might realize, oh, well, the buyer is going to infer the quality of the good from the price. So, well, I can just jack up the price, and it implies that the good is high quality. And then if you do the recursive computation one step deeper, then the strategic seller might realize that, oh, well, the buyer is going to realize that if I artificially inflate the price, then it's giving a signal that's high quality. So the distributions kind of even out. And I thought this was really fascinating, the way we could kind of recreate an interesting economic phenomenon just on top of choreographic programs. OK, so that's kind of like the high-level overview of this idea. I just want to touch a little bit on sort of directions for future work that I'm interested in looking into. So the first of these is sort of producing a formal semantics for Pact. So what I've presented has kind of a rough implementation in Python. But this is more as a proof of concept. I'd really like to sort of sit down and write down a formal semantics and a formal mapping between these two formalisms, between sort of Pact programs and games specifically, and sort of answering questions about how we can actually map between these and recursive theory of mind models. The second thing is about integration with cryptographic or encryption primitives. So at the start of this talk, I mentioned that a choreography really has no means of enforcing that an agent does a particular local computation. But if we incorporate cryptographic primitives, then we do have means of enforcing that. Maybe we can enforce that the agent sends us a sort of zero-knowledge proof that they did the computation in the right way. And so this maybe opens up the door for Pact being a sort of medium to allow integrating cryptographic primitives into some sort of distributed protocol. And the final direction is, I think, this work has primarily been centered around the buyer-seller protocol, because that's pretty ubiquitous in choreographic languages. But I think it would be interesting in a test of this formalism to see whether we could actually take other kinds of game theory examples and encode them within a choreographic language. So things like Vickrey auctions, or English or Dutch auctions, for example, or like cake cutting. Right. So that's kind of like that's the overall that's my high-level idea. So the key takeaways: if we want to sort of scale and enable autonomous interactions between agents, then agents should really agree on their interactions before they run them. They shouldn't be talking in natural language. And if we want formal guarantees, then these should be in a formal language. A choreographic language is presenting at the Choreographic workshop. And Pact is kind of the proposal that we've put forward as that language. So thank you for listening. I'd be happy to take any questions.
Thank you very much for the really interesting talk. I'm a little bit curious about this quality that you have there, because the foundation of a lot of economic work for the last 100 years or so has been the subjective theory of value, right? Like, I don't agree with you on what the value of this is, and it seems like you're encoding a objective theory of value inside of Pact. So do you see that as a something to overcome, or do you see that as a modeling choice that's reasonable for some reason? What am I missing there?
Yep, so thanks for the question. So I would say that, so the question was whether it made sense, whether this interpretation assumes a sort of subjective or objective theory, objective sort of description of value. And in particular, I think actually this is, maybe my explanation was unclear, but I think this is actually a subjective notion of value. Because when you do specifically in the Pact protocol, we don't actually specify what this function is that maps between the quality to the utility that an agent receives, right? This is something that's injected when you do the endpoint projection. So the seller would have to decide, okay, I believe that the buyer values it according to this function, and the buyer would also inject their own beliefs.
Okay, I thought the quality was the utility, so that's where I was getting
yeah.
confused. Okay.
Can we see the projected code?
I don't have slides on that.
One of my questions was, let me write it down. So kind of what I can do with Pact is sort of, I can analyze a game and see whether it's worth playing in the first place. But have you thought about, this kind of hinges on the idea that all the participants are actually going to obey the rules of the program that you've specified here. Have you thought at all about kind of a Byzantine setting where I, pretend that I'm Carol and I send a message?
Yeah, so I guess we've kind of elided that discussion in this work. So I know there are sort of like extensions to choreographic programs to incorporate things like faults and failure to deliver messages. So I think that could be extended on top of the core theory. So at least for this work, we're focusing on maybe the core like economic or strategic decision structure. But I think like choreographic languages are a nice formalism for this because this serves as a natural unifying point for integrating like all of these kind of developments that have been coming in from this community into this formalism.
Another question I had was, should I play this game that you've proposed?
So actually, you shouldn't. So I think this is actually recreating a phenomenon of market for lemons, which is that without kind of some impartial adjudicator of the quality of an item, the market kind of collapses. This is like with cars. You end up with like lots of lemon cars where people, the sellers will tell you that it's really good, and then it breaks down like after a week.
So is that visible like somewhere here somewhere eventually it gets to the point where like the probability of my getting any benefit as the buyer becomes zero and then I just decide not to play? Is that visible here, or where did you get that?
So that would come, I think, from solving the game for an equilibria, but that's not part of this. Once you map it to a formalism, then you can solve it for equilibria. But that's not, currently this is just like decision policies.
Got it. Maybe Michael can start setting up.
Mm-hmm.
And do we have any more questions? Maybe I could ask one more.
So one question I had watching this was, you're not choosing what the local program that gets run is, which is like one of the key things that separates choreographies from like multi-party session types. So I guess the question is, why is choreographies and choreographic programming the right thing here as opposed to something like multi-party session types?
So I guess maybe, I'm not sure. I guess maybe we can talk about offline. I guess choreography, I thought that this was a good formalism. Maybe multi-party session types might be a better.
Yeah, I don't think it's a bad one. I wonder if there's a better one. But maybe not.
Okay, yeah.
It's a great formalism. All All right, let's thank the speaker one more time.